Graph the function f of x equals x minus 1 over x squared minus 4. This is an example of a rational function. It is in the form of a polynomial divided by another polynomial. In order to graph a rational function, the first thing we must do is find the vertical asymptotes. We find the vertical asymptotes by setting the denominator equal to 0. So we will set the denominator x squared minus 4 equal to 0. We will solve for x by factoring x squared minus 4 into x plus 2 times x minus 2. Using the zero product rule, we would then set each of these factors equal to 0 and find that the vertical asymptotes will be the vertical lines x equals minus 2 and x equals positive 2. The next step is to find the horizontal asymptote if one exists. If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0. In this function, the degree of the numerator is 1 and the degree of the denominator is 2. So we see that the numerator degree is less than the denominator degree, so the horizontal asymptote will be the horizontal line y equals 0. So we have found the vertical asymptotes to be the vertical lines x equals minus 2 and x equals positive 2, and the horizontal asymptote is the horizontal line y equals 0. We now must determine if and where the graph crosses the horizontal asymptote by setting the function equal to the value of the horizontal asymptote. In this case, that is y equals 0. So we will substitute 0 for f of x and solve for x. We would do that by multiplying both sides by x squared minus 4 in order to clear the fraction. This would result in 0 equals x minus 1, and adding 1 to both sides, we find that x is equal to positive 1. This tells us that there is an x value for which this function value would be equal to 0, and that is the dot 1, 0. So the graph crosses the horizontal asymptote at x equals 1. We can divide the coordinate plane into 3 parts using the vertical asymptotes as boundaries. We would have the part of the coordinate plane where the x values are less than negative 2, the part where the x values are between negative 2 and 2, and the part where the x values are greater than 2. So we'll plot some points in each one of these areas in order to find out what the graph looks like. So beginning with the part of the graph that is to the left of where x is equal to negative 2, we could find f of minus 4. f of minus 4 is equal to negative 1/2. So the point negative 4, negative 1/2 would be on the graph of f of x. Substituting negative 3 in for x, we find that the y value would be negative 4/5. So the point negative 3, negative 4/5 would be on this graph. We know that the graph must approach the asymptotes, and it doesn't cross the horizontal asymptote at any point other than the point 1, 0. This means that for x values that are less than negative 2, the graph would be a curve that approaches both the horizontal asymptote and the vertical asymptote below the x-axis. Now we will substitute values for x that are between negative 2 and 2 to find out what the graph looks like in between the vertical asymptotes. If we substitute negative 1 for x, we find the y value to be 2/3. So the point negative 1, 2/3 would be on this graph. If we substitute 0 for x, we find that f of 0 is equal to 1/4. So the point 0, 1/4 is on this graph. If we substitute 3/2 for x, we find that the y value would be negative 2/7. So the point 3/2, negative 2/7 would be on this graph. We have already determined that the graph will cross the horizontal asymptote at the point 1, 0. So these points we have found are consistent with the notion that the graph will have to approach these vertical asymptotes and will cross the horizontal asymptote at 1, 0. So we will draw a curve then that has these characteristics. It will approach the vertical asymptotes infinitely and cross the horizontal asymptote at 1, 0. Now we will substitute values for x that are greater than 2 in order to see what the graph looks like to the right of the vertical asymptote x equals 2. If we substitute 3 for x, the corresponding y value will be 2/5. So the point 3, 2/5 will appear on this graph. If we substitute 4 for x, we find that the corresponding y value is 3/10. So we find that the point 4, 3/10 will be on the graph. So we will draw a curve then that satisfies the notion that the graph will infinitely approach both the vertical and horizontal asymptotes.